Hi, Andy here for Rancher Government. Today we're going to talk about more of the same when it comes to these little features. One of them I think that's really kind of cool is integrating Fleet, which is our continuous delivery tool, into being able to automatically procure and configure downstream clusters in a cloud provider. First thing we've got to do, kind of take a look around, is we can go ahead and take a look at our continuous delivery. Actually, let's take a look at cluster management real quick. We see we don't have any downstream clusters. Pretty easy, pretty straightforward, right? What we're going to do is let's go to continuous delivery. And I want to kind of highlight some of the nice things about Fleet. That's the tool that we've got. So I've just selected the namespace. I'm going to select Git repos. So notice I've got a bunch of applications automatically deployed. I've got Flask Ghosts, I got little versions app, and Who Am I? Automatically deployed using the CD tool. If I go in and update the YAML in this case, it'll go ahead and modify, like Fleet will go look at it, and within about 45 seconds it'll apply it. One of the cool things I'm going to walk you through is being able to use a Helm chart that we publish for cluster generation. So what I'm going to do is I'm going to flip over to my shell and I'm going to go ahead and apply, and let me show you what it's applying. This will take a minute. And actually notice it's already downstreams popped up. Okay. Cool part of it is this is actually going to go and register. And I don't know if you noticed the dev AWS, this happened really quick, sorry. But the dev AWS showed up. So we can go under cluster management and we can see that it's already starting to provision EC2 instances. It's already provisioned 3 instances and we're waiting for it to check in. I'll leave it on the logs. So let me show you what exactly happened, right? So we're going to go over here to my Fleet, and these will be hopefully in the show notes. But what I've got basically is a template, and then I've got 2 files. So we're using the dev, which is our AWS dev environment. I have 2 files. One is the Fleet. The first one is basically this Fleet YAML tells Fleet where the Helm chart is, what the chart name is, what the release name is, and where it can find the values. The values are right next to it in the same repo. Notice I've got 128.8. There was another video, maybe coming out of order, I'm not sure, but there was another video where I showed about how to upgrade this. If I wanted to upgrade it kind of programmatically, I could go in here and edit it, do a version control, push, commit, push. Sorry, my brain's a little foggy. Do a commit, push, and merge, and then Fleet will see it and automatically make the change to the underlying cluster. But notice we're also deploying with some configuration options for the kube controller, the scheduler. This turns out to actually be the STIG, which is really nice. We've got the opportunity to enable different registries. We can define our node pools. We can define our node pool size. We can do individual cloud init things to the individual VM. So if we need underlying packages, if we need some kernel tuning, that has followed me over the last 10 plus years from having worked at Docker. Even some security settings. And again, we can define another node pool. We even have the ability, I've got to comment it out right now, but we even have the ability to automatically deploy applications underneath. This is actually built into the chart. For those that are looking for the chart, it's Rancher Federal, github.com, Rancher Federal, Rancher-cluster-templates. And like I said, hopefully this will be in the show notes. And from here, you can get a little more information. And here's the actual chart. If you go ahead and take a look at the chart, and there's some typical values for like DigitalOcean, Elemental, Harvester, custom AWS, things like that. So it's really easy to implement. Okay. We'll go back here over to Rancher and we can see that, okay, we've got some of the control plane stuff already up and running. This usually takes anywhere from 5 to 6 minutes, especially with AWS. I've run this a few times. What we'll do is I'm going to go ahead and pause here. I'll leave it on the provisioning log. I'm going to go ahead and pause here. When everything's up and running, then I'll show you actually potentially how to update it. I'll save that. That was already done in another video. When this is done, we'll come back and I'll kind of show you, give you a quick tour around. Stand by. Cool. We're back. Provisioning is done. Let's go ahead and take a look at the machine pools. Yep, right around that 5-minute mark. And while I had the video paused, let's go ahead and actually do a git commit. So I'm going to pull up my code editor. And let me go over to my Fleet real quick. This is a bit of a mess, but you know, that's life. So here's that same file. We looked at 128.8. Let's go ahead and set it to 128.11. Let's just see what it does. So I'm going to hit save, and then I'm going to commit upgrade AWS downstream to 8.11. Why not 28? We got to have the perfect commit, right? Isn't that how it goes as a developer? So we'll go ahead and minimize this. And what we can see is we can go to continuous delivery. We can go to Git clusters, look at the local again. We can see weight applied. So Fleet has already discovered the change upstream because it's pulling that Git repo. And it's going to go ahead and make the change. We can go back to the cluster manager. See, now it says updating. We can go to dev, and we can see it's already reconciling that first control plane node. And it's already updated the cluster definition to 128.11. So that was an incredibly easy way to kind of manage the upgrade lifecycle. In a previous video or other video, I showed how to do it manually, but this is a great way to kind of do it kind of programmatically, having that source of truth using the Fleet tool that's already built in. While this is going, I forgot to show you one specific file. It's that continuous delivery, that Git repo file that defines these things. I think that's kind of important. I have it right here. And really, it's a very simple definition. I'll even do the one for the downstreams, right? So you're creating an object called Git repo. There's the version. There's the API version. I'm giving it a name. It's got to be in the fleet-local namespace. That's just how Fleet works. But I can be very specific about a branch, about what the repo name is, and then also the directory. Because if you notice, I've got like the application directories. I have the downstream cluster directory. You can logically sort this any way you want. This is just the way I've kind of do it just for my demos. And let's just see real quick how quick it is. Yep, we can go back here to the AWS and notice it's already on a node 2, and it'll quickly be on the node 3. Again, very simple way to manage your clusters programmatically through a version control. I hope you found this very useful. Please like, subscribe, share, all the YouTube-y things. And if you've got any questions or comments, please feel free to add them to the show notes, and then we'll hopefully be able to answer them quickly and provide any videos or anything that kind of helps the knowledge moving forward. Thanks for watching.